Hey everyone, welcome to Technical Ecology. I am Kalpapran and I am a biodiversity conservation student at Nottingham Trent University. In this channel, we talk about the technicalities, concepts and theories of biodiversity conservation and ecology in general. So if you're interested in that, make sure you subscribe and we'll get on with today's video. So in today's video, what we are going to learn about is R. So I will make a series of videos on R which will teach the basic concepts that we need to learn on how to use R, for especially in line with ecology. In today's video, what we are going to discuss are the basics of R, how to install R, what's the R IDE, and what's the R GUI, and all the basic concepts which one needs to just get habituated and familiar with R. Without much further ado, let's get into it. So first of all, what we're gonna do is install R, and then we will install R IDE. So to install R, we need to go to this website called Comprehensive R Archive Network, or in short CRAN. So the website is cran.rstudio.com or cran.r-archive network project. We will go to the second one here. So according to your operating system, if you're using Windows, then you download Windows. If you're using Linux, then you download, I don't know what, Fedora or Ubuntu. I think these are different versions of Linux. But yeah, you can do it from here. I have a Mac, so I'll download R for Mac OS, and I'm not using an Intel based Mac. I'm using a Apple Silicon based Mac, so I'll download R 4.3.1 ARM 64 PKG. If you're using an Intel, make sure you install this and not this one, because it's not gonna work. Okay, so I already have it installed, so I'm not going through the installation process again, but for you, it's just, you just keep on going over each and every step and then just go ahead with the basic installation steps. Okay, now since I have R installed, what I will do now is show you how to install RStudio. RStudio is an IDE, so an integrated development environment, if I'm not wrong. Yeah, an integrated development environment. So an IDE makes the process of coding much easier because it has much more features compared to the base version of R, the R GUI or the R graphical user interface. So for downloading RStudio, but it's called Posit now, you have to go to RStudio. There we have it, posit.co. So it's a free website, but if you use it for collaborative work, you'll have to pay for it. You also have a online version of it, which is helpful if you don't have a much powerful computer and you want to do all the computing over cloud. So you can just press download RStudio and then download RStudio again, and then you can see here that you can install R, the base version of R software, from here as well. It will direct you to the R CRAN website. And to install RStudio, you can install it from here. I have already again downloaded it, so I'm not gonna go through the installation process again. So once we have this all installed, I would want to show you R as a base version. So this is the R software that you downloaded, and RStudio is the one that you are gonna use. So when you open R, you can see that there is this R console, which is where you basically do all the one-line commands or two-line commands. So what R is basically, R is an interpreted language, which basically means that you have specific syntax and specific set of code that you write in a certain manner following the R language, which kind of computes that code and gives you the results. So when we open this our app, this is the base version, this is the default graphical user interface. However, we will be using Posit, like I told earlier. So Posit has a much more interactive and much more better looking environment. Anyway, what I want you to know is that most of the coding will be done in our Posit, so we are not going to go over each and every panel or each and every script for the base R version. So I'll just go ahead and close this and open RStudio. There we go. Let me just quit this here. So you can see here I already have a script ready, but that's for the for today's video. Anyway, so you can see here that we have something called the console. We also saw the console when we opened the base R version. There's something called terminal. I think it will be a command prompt for Windows users, and we have the background jobs that are like currently running. Okay, let me get rid of this. Just there we go. Okay, now so we can see that we have the console here, which is very similar to when we ran the base R version. If I just run R again, I will show you. See, you can see here it's written the R console. So the console is where you use directly only if you're writing short one-line commands, but if you're writing much larger and more complex code, we use something called the script. So the script is when you press this, you can see that when you press Command Shift and N, then it'll open up a new script. So you can say that these all are scripts. So what I mean by complex command is something like assigning a variable a certain value. So you do that in the R script, and then you compute. Let's say we assign a variable called x, and we assigned it a value of 10.29, and then we assign a variable c, which we assigned a variable of 10.29 as well. Now if we need to multiply 10.29 into 10.29, we can directly use the variables to do it, and we can do that in the R console directly. Or what we can do is we can have x into c and then store it in another variable, and then we just print the variable in the console and we get the results of the command. I know it kind of sounds confusing right now, but I'll show you examples of it, which will make it much more easier. But before we get into the complexities of making variables and computing data, let's just get a basic idea of what are the basic things that you need to know when you use R in general. So I have my notes here just in case I forget something. Like I mentioned again, for longer chunks of code we use the editor, and our script, these scripts are basically text files. So like if you know proper like original computing .txt files, those are called text files, and they are like plain text file. Even our script is a plain text file, but it is stored with a extension called .r. You can see ep1 script point r. I mean, ep1 is basically the first episode that I'm recording for YouTube. Okay, so let's get into it. You can see here that I have used hashtag. You don't have to use hashtag together. Even if you just use one hashtag and then you write something, let's say green, or no, let's say hello world. So you can see it comes in a different color. But if you write hello world and then you try, this is in a different color. So basically what hashtag does is it turns anything that you write on the script into comment. So by comment, what I mean is that let's say you have this set of code like get wd. So if you are used to coding, then you know, okay, what get wd does. It's a function that gets the working directory, about which I'll come back to later. But let's say you know, but you're giving it to somebody who doesn't know much about coding. So then these comments come in handy. Like you can see here that I've mentioned hashtag to get working directory use da, da, da. So to get the working directory, we use this function called get wd. So this is basically the use of comments to kind of annotate your code. It's helpful for somebody who's using your code, but it is also helpful for you, because if you're writing a very complex function and you forget the specifics of it, you can always annotate the specifics, so that when you're going through it, it's much more easier and much more comprehensible. Anyway, now where I want to come is to the working directory. So the working directory is basically a folder in your computer where all the R scripts and all the R objects are stored. We can use this function called getWD to get our working directory, to get the path to our working directory. So what I want to show you is getWD as of itself doesn't do anything if you press enter. But if you select this piece of code and then you press run, or command and enter for Mac users and control and enter for Windows user, it runs the code. So it runs this chunk of code which returns this user. This is the path in which the R files are stored. So let's check if this path exists or not. So to go to this path, I'll go to my Finder, and then I'll go to my computer, my contact, users, and Kalpan. See, this folder exists. So whatever you do here, whatever changes you make, whatever, let's say you kind of create an object and then save that object, it will be stored in this path, Kalpan. This folder is where those objects will be stored. Now, where the R script is stored is somewhere totally different. So R script in of itself, if you don't change the path of it, it will be stored in the folder called Kalpapran. But let me just show you. Let's just type something, and let's say my name, Kalpapran. Okay, now I want to store this. Now if I just tap command S, which stores the script, you can see it wants to store it here in the folder called Kalpapran. So I'm not going to save this, but this is what I wanted to show, what the working directory does. Now it's a good practice to have all the files that you're working with in R, to have it in one working directory, so that you can directly just use the name of that file along with its extension to import it and work with it. Or else, if you are very comfortable with typing down the paths in which those specific files are saved, then you can go ahead and do that. But the path is, as you can see, is always in double quotations or single quotations in any of those. So whenever you write a path, you can change the working directory, which I'll show you now. Is if you want to set a new working directory, there's a much more easier way than just typing in. So you can see here, when you go to sessions and then you press set working directory, then you can set the working directory to source file location. The source file location is where the R script is stored. Now let's and to the file, if I choose directory, then you can see that I can change the working directory. Now since my R script is in a different folder, I will store it in a folder which contains a script, and I'll store all my files that I'm working with in that specific folder. So go here, I'll choose directory. If I remember it correctly, I have stored in YouTube and R scripts. So you can see here is where I store all my R scripts. So for this EP1, actually I'll create another folder called EP1. Create, and then what I'll do is I'll move it. Okay, I'll store in something called EP, and I am going to store my EP1. Just move it, come on. Oh, sorry. There we go. So here we have it. Now in EP1 I have my script, and all the other things that I'll be working with will be stored in that specific folder. So it's much more of a housekeeping rather than convention. Okay, so you can see that when I moved it, it shows that the file is there. So do I want to close it? I'm like, right, fine, I'll close it. I'll open it again. So go to file, open recent files. Yeah, I have it. There we go. Okay, the directory is not there. Anyway, projects, YouTube, R script, EP1. See, I'm not kind of editing my mistakes in this video because I really want you to keep a note of it. The mistakes that I make will help you learn more about, okay, you shouldn't do this, you shouldn't do that. Anyway, I open this, and then we have the script back again. Okay, I also want to let you know that when you are typing a file path, if you want to change the working directory and you're typing a file path, or even if you want to import let's say a CSV file into R, file path is case sensitive. So if a file is saved as, let's say, Oppenheimer, then if the O is small, but if you type it as O as big, it won't read it and it will throw up an error. Similarly, this is not a problem with Mac, but I've seen that when I use Windows, the slash that divides each folder, let's say, because I'll show you here, you can see that these forward slashes divide the folders. It goes into subfolders. It's a backward slash in case of Windows, which will again throw up an error. You always need to use forward slash. Okay, so now let's get into something called packages. So you can see here that there is this dialog box called packages, and all these are packages. So what are packages? So let's say a package is a pocket of very specific functions. So in and of itself, R has many functions that we can work in, many arithmetic function, many statistical analysis function, plotting functions, visualization functions. But sometimes we need to get into the specifics of it. Let's say in ecological studies, capture recapture is used many times. So there are many packages like spacecap, which is used for Bayesian capture recapture analysis, or SCCR for maximum likelihood spatial explicit capture recapture techniques. And I think there's also a function called OSCR, which is used mostly for, which is developed by the Snow Leopard network. Anyway, so these packages, they have specific functions which are used for specific use. Let's say you want to have a way more vivid and a way more diverse range of visualization, which is not in on itself available in R as a base package or as a base function. So you can use something called ggplot2, which has many different sorts of visualization functions. So how to load a package? So to load a package, we use the function called library, that is, or we can also use something called require. It's always a good practice to load the packages as you go. So let's say you want to use a ggplot2, then you just load the package ggplot2 once in the top of the code, where it kind of stacks up all the packages that you're using, and it's much more easier for you later. It is especially important when you're coding a very large script. So the function library, there's a package called lattice. So if I call this function lattice, now it loads up the package lattice. Now you can see here, if we just scroll down, we'll go to L. Here you can see that this is the package lattice that we loaded. So if we just turn it off, you can see that it detaches the lattice package. So if we use any function of lattice now, it won't run because it's no longer loaded in. So in order to load in, you can either scroll here and just click this and it loads it, or you can just type in this command line and then run it. Now this feasibility of just clicking here and loading it. It's not available in the base R version, the base GUI of R, where you actually need to type the code in their script and then run it. So this is another very helpful feature of using an external third-party IDE like RStudio. So that's something you need to keep in mind. Now, to install package, like I spoke about ggplot2, you can see here that I don't have ggplot2 installed. Actually, I had it, but I deleted it just for this example. If I go to G, you can see here that there's ggplot2 is not available. So to install a package, it is usually downloaded from the R grand website that I talked about earlier, the comprehensive R archive network. Sometimes you can also download you can also download packages like OSCR from GitHub, but then you need to have the proper URL to it from where you are importing. Anyway, for now, what we are going to do is we are going to install ggplot2. Okay, the function called install.packages installs ggplot2. There's another way. Again, it's again a benefit of having an third-party IDE. You can go here, you can go to install, see repositories, grand repository, where you can just type in ggplot2. So if you press here and then you press install, it will do the same thing as, it'll just basically call the function install.package ggplot2. But since we know the function here, let's just run it. So you can say it'll go online and then it'll download it, and it gives you the path in which this is stored, this package is stored. Now you can see it has turned up here. You can see ggplot2. Now you can load the package by pressing here, or you can again detach the package. Sometimes what happens is that packages are continuously updated, so it is a good practice to stay up to date with a package, or at least find a substitute if there is no update for the package and the package is being discontinued, like the raster package, which I worked my entire dissertation on, but it's now getting discontinued in October. So I will probably need to run everything and then change the package and the functions associated with it. Anyway, that's a different conversation altogether. So to update package, there is a package called spatial. I'll show it to you here. You can see yeah, there, functions for bringing in point pattern analysis, is basically for spatial data. This package, it's not up to date. And how can you check if it's up to date or not? You can just again go here, update, and then you can see all these packages are not up to date. So there are updates available, and if you press news, then it'll show you the details of the update. What you can do here is again press, let's say this package called NLME. We want to install the update for it. We just select it and then we install it. So you can see that it basically runs the same function that I've written up here. You can see it install.package NLME. So it basically installs the package from the beginning again, instead of just updating it. So if we run this function called update.packages for spatial, we can see that okay, yeah, I think it updated. Let's see, update. Okay, interesting. Usually okay, let's see. Usually when in the base R version, when I tried this, when I ran it, it installed the update to it, but probably just because we have the update option here, Posit doesn't have this function to run it. Anyway, what I basically wanted you to know is that packages need to be updated like time and again, because it has many bug fixes, and it helps to keep the code running smooth. Like sometimes the code just might not run, and that might be because of a specific bug that's there, and that can be removed by future updates by the developer. So for now, I'll just update all of them. Let's just update all of them. Okay, now let's say you have package, and then that package is a specific function, but you don't know what that function does, or at least you don't know what are its arguments. So by arguments, what I mean is that if you run the function called mean, which computes the mean of something, whatever you put inside this parentheses are called the arguments. So the arguments are in a very specific order. You can't change the order. Sometimes you can, which is again very confusing in coding, but usually whenever you have an argument, you have a variable to it, and then you write equals. So let's say x equals something, and then mean equals something, or let's say SCP, which is a separator when you are importing something. Let's say importing a CSV, and you want the separator to specify the separator as comma, then your SCP then equals to in double quotation comma. So basically whatever goes inside these parentheses are the arguments. Now if you don't know that, let's say we don't know that, we want to know what are the arguments, what that function does, what you basically do is just type a question mark and then just beside mean, and then you just run it. So I'll just run it from here for now. You can see it brings up our documentation page where it shows you the mean is the generic function for finding out the basic arithmetic mean. So you can go over this entire document and then just learn about how the package functions. So now you can see here that the arguments here, x is the object for which you want the mean. Let's say we have a vector of 10 values and we want to know the mean of those values. Then we have a vector called x equals, we have c, which is you concatenate 10 variables, about which we'll learn more about in the next episode. Na.rm is used again if it is basically a boolean value. You just assign na.rm equals to true or false depending on if there are any na values in the dataset. So those are basically the arguments. Now you can read through all of this and get more idea about the about this function. But what if you're unsure which package does the function belong to? Now there are many instances where you have one function in many packages and you don't know from which package it is running. Let's say you want to compute the mean of a raster. You can the function for calculating mean is same for the function that's available in base R, which calculates the arithmetic mean. Now to get that, you just type 2 question marks and then you just type the function. It will show you all the packages that have the function mean in it. So you can see that there are many. So you can go to the specifics of it and then read how it's worked according to the package and according to your needs. So now we are kind of coming to the end of this video, but what I want to show you before we end this video is that it's always a good practice to save your R script, because just in case R crashes, then you can kind of come back and then rerun the code again. Like you don't lose the code, or especially if you're working on a code that's very long and it takes like weeks to code, and so it's always good to come back to a script and then write everything rather than writing everything from scratch every time you open R. So what you can do is you can go to file and then save as, and then save the script, or command and S, then it just saves the script. If you save it for the first time using command S, then it will kind of show you where you want to store it. So it's basically save as, and then it will show this panel where you can store it. Like you can see that I'm storing it here in this folder called EP1. And the last thing is that you can also store the entire R workspace. So if I press this, you can see that it will show me to save the entire R the R workspace in general. So what this does is that if you have let's say a certain vector, I'll show it to you. If you have a certain vector, let's say I assign this vector a variable of 78, and then if I run it, you can see that this is an R object now. Now if I save this entire R script along with the R workspace, in this folder called Kalpapran Patur, it will store this object called x equals to 7 as well. So the next time you open R, you don't need to run this code again. The value to x will already be assigned. So basically that's the function of saving the entire R script. And the final thing which I want to tell you is the convention of coding. So it is all there are many good practices of coding which I'll show you in real time when I'm coding with you from the next episode onwards. One thing that I want to convey in this video as well is that it is always better to have your line of code less than this dividing line. You can see that I have written in here it's way more difficult if it's a very long line of code that you have written, or very long comment. Like if I write specific help, what is your name and all the stuff, then you can see that it kind of cuts off, so you need to keep on scrolling, which is just a hassle. It doesn't harm your code, but it's just a hassle to read, or even read the code in a more fluent manner. So it's always better practice to write your code behind this line and not exceed this line. But this is again subjective. It works for me, it might not work for you. Do whatever is best for you. But yeah, this is one coding convention that I wanted to put in this video. So with that being said, I think we have come to the end of this video, and I hope to see you back in the next video where we go into the basic arithmetic functions, how to assign variables, different kinds of data sets, and all the different shenanigans. Okay, see you in the next video.